find the work done by this force field in moving an object along the path sine t I plus cosine t j in between 0 and pi over 2. First, let's check if this force field is conservative. Okay, and we always say the first component P. So here for the force field, the component P is y squared plus 2x ey plus 1, and Q is 2xy plus x squared ey plus 2y. Note that the domain of this force field F is all the points in the plane, all xy or R2. So if the following two partial derivatives are same, partial of p with respect to y is same as partial of q with respect to x, if they are same, and since the domain is all the points in the plane, that means the domain is simply connected, then F is a conservative force field. Let's find the partial of p with respect to y. That's 2y plus 2x, bf's like constant, ey just ey, plus derivative of 1 is 0. How about this with respect to x? So 1, so 2y plus x squared, that's 2x, ey is constant, plus derivative of 2y is 0 with respect to x, and they are same. Okay, that means this F is conservative. Then we can find a potential function. Okay, that means then we can find a potential function F of two variables x, y, such that partial of F with respect to x is p, the first part, which is y squared plus 2x ey plus 1, and partial of this potential function with respect to y is second q, 2xy plus x squared ey plus 2y. Okay, now forget about these two partials. They were needed just to check if the force field is conservative. Now you work on this. Okay, F is conservative means basically we can find a function, new function, little f, and gradient of f is just f, which is this. Okay, so let's recover the function from equation 1 and 2. For, look, this is derivative with respect to x, and this is derivative with respect to y. So we can integrate 1 with respect to x. So integrate 1 with respect to x. So that means just the function that what we are looking for equals antiderivative of y squared with respect to x. So y squared is constant, so with respect to x means x. It's like 5, constant dx means 5x. Okay, and plus antiderivative with respect to x. So ey is constant, 2x, that's x squared, right? Because 2 times x squared over 2, just x squared ey, plus antiderivative of 1 is just x, and we get a constant. But that constant could be a function of y. Okay, not only a number like -5 or 10, it could be a function of y, because we were integrating with respect to x. So number 3, we were almost done, but we need to figure out what is h. For we will use equation 2. Look at here, equation 2 is partial derivative of f with respect to y. So let's find the partial of this f with respect to y so that we can compare with equation 2. Okay, so differentiate 3 with respect to y, we get f partial y is, so this is 2yx, ey is ey, x squared constant, with respect to y that's 0 plus h prime y. So when we find the derivative, this is a single variable function, okay, just one variable, so partial derivative is same as regular derivative, equation 4. Now let's compare 2 and 4. Left hand sides are same, 2xy, same thing here, x squared ey, same thing here, 0 does not count, so 2y is same as h prime of y. We get h prime of y is 2y. Integrate with respect to y, then we get h is a function of y. Antiderivative with respect to y is just y squared plus some constant now, okay, some number, and we can take 0 because we are looking for a potential function, so any constant would work. Now go back in equation 3, and equation 3, that's the f, that's a potential function. Thus f is 2 y square x, so equation 3, so x y squared plus x squared ey plus x plus hy is now y squared. Okay, let's go back and read the question. Now we are trying to find this work done when an object is moved along this path. So this path, let me write in component form. So this rt is in fact sine t comma cosine t, from where t runs from 0 to pi over 2. That means from this vector we can find the initial point of the path and the terminal point of the path. So initial point means plug in t equals 0. So when we plug in t equals 0, so initial point is then plug in t equals 0 here, sine 0 0, cosine 0 1. And how about the terminal point of the path? Okay, terminal point, plug in t equals pi over 2 here, sine pi over 2 is 1, cosine pi over 2 is 0, so 1 0. Okay, since this f is conservative, this work done is same as potential function evaluate at the terminal point minus potential function evaluate at the initial point. Okay, so that will be the case, and initial is 0 1, terminal is 1 0. So let me go down here. Then the work done moving along the path is equal to this potential function at terminal point minus initial point. Okay, 1 0 and 0 1. That is, evaluate this function at 1 0. Here is the function, just plug in x equals 1, y equals 0. Okay, so plug in 1 here, 1 times 0 squared 0, e raised to 0 is 1, 1 is squared is 1, x 1 plus 0 squared 0 minus f of 0 1, x 0, y 1, so this is 0, this is 0, this is also 0, 1 is square 1, so 1 plus 1 2 minus 1 1, final.